Hello, hi everyone. Welcome to the Student the Brand. This is our Shiva sir. Today topic is light reflection diffraction. Light reflection and diffraction. So now we'll discuss. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Okay, so here you can consider light reflection, light reflection and refraction chapter. Light reflection and diffraction chapter today. Okay. Light incidenting on surface, it reflect back. So here you can see. So I'm taking the plane surface. So this is a plane surface, reflecting surface. One side is reflecting surface, another side is coated one. Light is incidenting on it. This incident ray, reflected ray, and the normal line. The line which is perpendicular to the plane surface is called a normal line. The light ray which is, or actually the line which is perpendicular drawn, that is called normal line. Okay. So the light ray which is incidenting on it, incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. The angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. And if you are taking this surface, there's undeviated line. Normally, if the light ray passes, so you can observe when light ray is moving in a homogeneous medium, so it does not change its direction, it does not change its path, it moves in a straight line path. It moves in a straight line path. So here also, this is an undeviated line. Incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. So I'm taking this angle of deviation. So undeviated line, angle of deviation. Okay, so the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light, or reflecting back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface, okay, so it's called reflection of light, is called reflection of light. So here incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. And angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. So this is about reflection of light. And coming to laws of reflection. Coming to laws of reflection. There are two laws of reflections are there. There are two laws of reflection. So laws of reflection. Laws of reflection. Laws of reflection. Incident ray, reflected ray, normal line lies on the same plane. Point number one. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Okay, so angle of incidence is equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. So these are the laws of reflection. From laws of reflection, we can observe here, from laws of reflection, we can take angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Now, so we know angle of incident is equal to angle of reflection. By that, Angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. We can also take angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation equal to angle of deviation equal to 180 minus 2 angle of reflection. Okay, so like this also we can take, like this also we can consider. So either this way we can take. So incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Okay, so loss of reflection. Incident ray, reflected ray, normal lies on the same plane. Angle of incident is equal to angle of reflection. And angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. That is a linear angle. So on the same line. And angle of incidence plus angle of incidence plus angle of deviation equal to 180. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. Okay. So now we can take now. So we can take, we can consider one more, that is regular reflection and irregular reflection. So we'll discuss about regular reflection and irregular reflection. So you can see regular reflection and irregular reflection. Coming to regular reflection means incident light rays are parallel, then reflector light rays are also parallel to each other. The type of reflection is called regular reflection. Coming to irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. So regular reflection means if you are taking here, okay, so incident light rays are parallel. So reflector light rays are also parallel to each other. Reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. Regular. So here plane surface is smooth. Plane surface is smooth. Smooth surface. Okay. So surface is smooth. Best example. We can take still water and normal plane mirror also we can consider. Still water and plane mirror. So on it regular reflection takes place. Coming to irregular reflection. Irregular reflection. Okay. So I am taking the rough surface here. Rough surface. So incident light rays are parallel. So incident light rays are parallel. So I am taking here. These are the incident light rays. Here. Like this. Then reflector light rays are not parallel to each other. They'll move in different directions. Okay. So incident light rays are parallel, but reflector light rays are not parallel to each other. Okay. So now you can observe Incident light rays are parallel, but reflected light rays are not parallel to each other. So regular reflection and irregular reflection, regular reflection and irregular reflection. Right now, so coming to the object and image. So coming to, we'll discuss about object and image. So here you can observe here. So this is a plane surface. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. So I am considering here this object. One light ray I am taking like this. So one more light ray. After reflection, those are moving away from it. After reflection, those light rays are moving away from it. So if you are extending these light rays, those light rays are meeting at one point here. Okay. So here, real image, real object. Actually, this is a real object. And this is a virtual image. And one more you are taking here. Here. So light rays are coming like this, and here also like this. After reflection, so here real image, the point of intersection of incident light rays. So real image will form. So if you are extending these light rays, okay, if you are extending the light rays, so incident light rays are meeting here. This is a virtual object. Object and image. So now you can see this is the point of intersection of incident light rays. The point of intersection of incident light rays. So you can observe this is a real object and this is a virtual image. Here incident light rays are there. After reflection, light rays are meeting directly. Their image is forming. That is a real image. We are extending the incident light rays. Extended incident light rays are meeting their virtual object. Okay, object is real. So by this we can conclude that object is real, image is virtual. Object is virtual, image is real. Once again, object is real, image is virtual. Object is virtual, image is real. So we can conclude that object is real, image is virtual. Object is virtual, image is real. Vice versa. Okay. So this is about object and image. Coming to the virtual nature of the image formed by the plane mirror, we'll discuss about nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Now you can observe. So this is the plane mirror. So I'm taking the object is here. Object. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object, as we discussed now. Okay, so now one light ray I'm taking like this. So one more light ray I'm taking here, and this will be reflected back. So here we can observe, and one more light ray here, so it will be reflected back. And here I'm considering like this. Okay, so A, B, and A dash, B dash. Okay, A, B, and A dash, B dash, A dash, B dash. Okay. If object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. Okay. So object is real, image is virtual. Object is virtual, image is real. Point number one. Point number two, the distance between object to mirror is equal to distance between image to. So here the distance between object to mirror is equal to object distance. The distance between mirror to image is called image distance. So the object distance is equal to image distance. Object distance is equal to image distance, and the height of the object is equal to height of the image. Height of the object is equal to height of the image. And coming to the fourth one, so it is also shows lateral inversion plus 1. It also shows lateral inversion. And coming to the fifth one, okay, so it is m equal to plus 1. So T m equal to plus 1, magnification of the plane mirror is plus 1. Magnification of the plane mirror is plus 1. Okay. So, and it also shows lateral inversion. It also shows lateral inversion. Lateral inversion. Lateral inversion. It also shows lateral inversion. So what is lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. So what is the lateral inversion? Lateral inversion is nothing but the phenomena of converting of the mirror image. The mirror image, the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Best example, you are standing in front of the mirror, you raise your right hand, it appears in the left side of the image. So if you are standing in front of the mirror, if you lift your left hand, it appears in the right side of the image. Okay, this mirror image is called lateral inversion. This mirror image is called lateral inversion. Lateral inversion. I hope it is very clear. So this is about nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Next one. So we'll discuss about spherical mirrors. So we'll discuss about spherical mirrors. Spherical mirror. Spherical mirror, right? Yes. So just 1 minute. Okay. We'll discuss about spherical mirrors. The mirrors which in the form of curved shape, the mirrors which are in the form of curved shape, those are called spherical mirrors. Depending on the reflection of light. So I'm taking like this. Okay, so you are taking the concave mirror. Depending on the reflection of light, mirrors are divided into two types. So concave mirror and convex mirror. Concave mirror and convex mirror. So here this is a concave mirror. Concave mirror is also known as converging mirror. So concave mirror is also known as converging mirror. So because when incident light rays are falling on it, so here also after reflection those light rays will meet at one point. Okay, so here you can observe these light rays are meeting. After reflection light rays are coming closer. After reflection light rays are coming closer, moving towards. Okay, so one point, that's why it is called concave mirror. So concave mirror is also known as converging mirror. Okay, so light rays are moving towards the principal axis. Concave mirror is also known as concave mirror is also known as converging mirror. Converging mirror. And the convex mirror is also known as diverging mirror. So you can observe here. So here I am taking like this and here. So convex mirror is also known as convex mirror. Convex mirror is also known as diverging mirror. So concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Why? So why we are calling like this? So concave mirror, whenever light rays falls on it, after reflection, light rays are moving towards the principal axis. So here you can observe carefully. After reflection, light rays are moving towards the principal axis. Here you can observe after reflection, light rays are moving away from the principal axis. After reflection, light rays are moving away from the principal axis. So that's why concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Okay, now so we'll discuss about ray rules of concave mirror. Ray rules of concave mirror. So we can take ray rules of spherical mirrors. So ray rules of concave mirror. Concave mirror, convex mirror. Concave mirror, converging mirror, convex. Concave mirror, convex mirror, concave mirror, converging mirror, convex mirror, diverging mirror, convex mirror, diverging mirror. Okay, done. So that is about concave mirror and convex mirror. Now we will discuss about ray rules of concave mirror. First point, so I am taking here pole, focus and center of curvature. This is the pole, focus, center of curvature. So light ray is coming from infinity. After reflection it passes through focus. Light ray is coming from infinity. After reflection passes through focus. Coming to the second one. So this is the pole, focus, center of curvature. So light ray is passing through focus. After reflection moves towards infinity. And coming to the third one. So light ray is this is the pole, focus, center of curvature. Light ray is passing through center of curvature. So and coming to the fourth one, light ray is incidenting at the pole, focus, center of curvature. Light ray is incidenting at the pole, so it will reflect back. So these are the ray rules of concave mirror. So one is light rays coming from infinity after reflection passes through focus. Light rays passing through focus. Once again, light rays coming from infinity after reflection passing through focus. Light rays passing through focus. After reflection, it is moving to infinity. Light ray is passing through center of curvature. After reflection, passes through, retrace its original path. Light rays incidenting at pole, it reflects back into the same medium. Next, we are going to convex mirror ray rules. We are discussing about convex mirror ray rules. First one. So pole, focus, center of curvature. Is this concave mirror, convex mirror? Concave mirror. What we are going to discuss? Convex mirror. Yes or no? So convex mirror like this. So here I am taking like this. So pole, focus, center of curvature. Light ray is coming from infinity. Light ray is coming from infinity. After reflection, it passes through focus. After reflection, passes through focus. Second one. So light ray is passing through focus. After reflection moves towards infinity. Understood? Coming to the third one. Pole, focus and center of curvature. Light ray is passing through center of curvature. So it retraces its original path. That is the third one. Coming to fourth one. Pole, focus, center of curvature. Light ray is incidenting at the pole, it reflects back. These are the ray rules of concave mirror and convex mirror. Concave mirror and convex mirror. Concave mirror. Light rays coming from infinity after reflection passes through focus. Light rays passing through focus after reflection moves towards infinity. Light rays incidenting at the pole, it reflects back. Light rays passing through center of curvature, it retraces its original path. Coming to convex mirror, light rays coming from infinity after reflection passes through focus. Light rays passing through focus after reflection moves towards infinity. Light rays passing through center curvature, so it passes through center curvature. After reflection, it retraces original path. Light rays incidentally about at the pole, it reflect back. So this is about concave mirror and convex mirror, ray rules and image formations. Now we are going to discuss about nature of the image formations by concave mirror and convex mirror. Even though nature also we will discuss. Nature is nothing but converging nature or diverging nature. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see. Near distance we can see. Far distance we can see. Myopia, myopia, myopia. For that direction we are using concave lens, concave lens, concave lens, concave lens. New Cartesian sign convention, new Cartesian sign convention, all a distance measured from the pole. Distance positive along the incident ray. Distance negative opposite to incident rays. Distance positive above the principal axis. Distance negative below the principal axis. So now we will discuss about terms related to spherical mirror first. Terms related to, then we'll go to the image formation. Terms related to spherical mirror. Spherical mirror. Spherical mirror. Spherical mirror. Spherical mirror. Spherical mirror. Yes, terms related to spherical mirror. Okay. So now you can observe here. I am taking a concave mirror, concave mirror, concave mirror, concave mirror. Oh my god. Concave mirror. Concave mirror. Terms related to concave mirror. So pole. The midpoint of the mirror is called pole. And the center of the imaginary sphere. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. And the center of the imaginary sphere in which mirror is a part is called central curvature. The distance between so the distance between central curvature to pole is called radius of curvature. The distance between central curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. All light rays are meeting at one point on the principal axis is called focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length, focal length, focal length, focal length. Center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The distance between central curvature to pole is called radius of curvature. And after reflection, all light rays will meet at one point on the principal axis. Is called focus. And fifth one, the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Width of the mirror is called aperture. Aperture. And the seventh one is center curvature, pole, radius of curvature, focus, focal length, principal axis, principal axis, principal axis, the distance, the line joining of central curvature and pole is called. The line joining of central curvature and pole is called. Pole is called principal axis. Come on, everybody, do class for principal axis. Welcome. Welcome, principal axis. So, everybody, welcome to the principal axis. Our new important main role, key role is playing only principal axis. Only principal axis playing very important role. Key role is the hero of the entire diagram. Center of the curvature, the center of the imaginary sphere in which mirror is a part. Pole, midpoint of the mirror is called pole. The distance between focus to pole is called radius of curvature. After reflection, light rays will meet at one point on the principal axis called focus. The distance between focus to pole is called focal length. Width of the mirror is called aperture. Width of the mirror is called aperture. Very good. Come on. Give a big round of applause to aperture. Next. Principal axis. Principal axis. Principal axis. The line joining of center curvature and pole is called principal axis. The line joining of center curvature and pole is called principal axis. Terms related to spherical mirror. Terms related to spherical mirror. Spherical mirror. Next one. Now our turn. Now our time. Time aa gaya. Now terms related to interaction to the main key role, the main important role for problem, for concept, for marks, for entire chapter. That is terms related to spherical mirror. In that, very important, very important concept is concave mirror. In concave mirror, ray rolls, there are 6 image formation. Ray rolls are 4. Image formations are 6. Okay. Are you understanding? Image formations. Image formations. Image formations. Image formations. There are 6 image formations. In concave mirror, 6 image formations in concave mirror. Point number 1, light rays are coming from infinity. Light rays are coming from infinity. Pole, focus, center of curvature. Pole, focus, center of curvature. Object is at infinity. Object is at infinity. Come on. One light ray I am taking like this, another light ray I am taking like this. After reflection, light rays are meeting at focus. After reflection, light rays are meeting at focus, 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 focus. After reflection, come on. Object is at infinity. After reflection, light rays are meeting at focus. After reflection, light rays are meeting at focus. Come on, come on. What is the image formation? Image is real and inverted. Real and inverted. What is the nature of the image? Real and inverted. What is the size of the image? Highly diminished. Oh my God, highly diminished. Point size image is forming at focus. Highly diminished. Okay, next is going to the next one. Concave mirror. Concave mirror. Pole. Focus. Center of curvature. Pole. Focus. Center of curvature. Object is placed at. Object is placed beyond center of curvature. Object is placed beyond center of curvature. How many light rays are required to image of the object? How many light rays are required? How many light rays are required to form the image of the object? How many light rays are required to form image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. I am taking one light ray like this. After reflection passes through focus. After reflection passes through focus, another light ray I am taking through center of curvature. After reflection, it reaches the original path. Where image is forming between C and F. What type of image is forming? Real and inverted. What type of image is forming? Real and inverted. Object is placed beyond center of curvature. Beyond center of curvature. Where image is forming? Image is forming between C and F. Between C and F. What is the nature of the image? Real and inverted. What is the nature of the image? Real and inverted. Real and inverted. Size of the images. Size of the images. Diminished. 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 Okay, okay, okay. Next one. We are going to the next one. Object is placed at center of curvature. Are you all ready for it? Witness the greatest image formation. The greatest of our history is going to happen. This is ball, focus, and center of curvature. Object is placed at center of curvature. Where image is forming, object is placed at center of curvature. Image is forming at center of curvature itself. Image is forming at center of curvature itself. What is the nature of the image? Nature of the image is real and inverted. Size of the image is same size. So size of the image is same size. Are you understanding or not? I am saying to you itself. Size of the image is same size. Nature of the image is real and inverted. Object is center of curvature. Object is center of curvature. Image is also at center. Image is formed at center of curvature. Nature of the image is real and inverted. Real and inverted, and size of the image is same size. Same size. It is very, very important. Image is forming at center of curvature. Nature of the image is real and inverted, and Size of the image is same size. Coming to the fourth one, object is placed between center of curvature and pole. Object is placed. This is center of curvature. Pole. Pole. Center of curvature. Focus and pole. Focus and pole. Focus and pole. Object is placed between C and F. Object is placed between C and F. What is the nature of the image? Real and inverted. What is the size of the image? Size of the image is object is placed between center of curvature. Object is placed between C and F. Image is forming. Image is forming beyond center of curvature. Image is forming beyond center of curvature. What is the nature of the image? Nature of the image. So object is placed between C and F. C and F. Image is forming beyond center of curvature. Beyond C. Nature of the image is real and inverted. Size of the image is enlarged. Enlarged. Except in this case, remaining before this case, image is real and inverted and diminished. After this case, real and inverted and enlarged. Next one, fifth one, where object is placed. What is the nature of the image? Now we are going to discuss about the nature of the image. If you place the object at center of the object is placed at focus. Pole, focus, center of curvature, object is placed at F. One light ray I'm taking like this, it passes through focus. Another light ray is incidentting at the pole, it reflects back. Object is at F, image is forming at infinity, nature of the image is real and inverted, of the image is highly enlarged. Highly enlarged. Very, very important, highly enlarged. Okay, so next one, sixth one. Sixth one. So pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed between F and P. One light ray I am taking like this, it passes through focus. Another light ray incidenting at the pole, it reflects back. So if you are extending like this, the image will form here. So the image will form behind the mirror. Image will form behind the mirror. Nature of the image is virtual, erect and enlarge. Virtual, erect and enlarge. So object is placed at infinity. Image is forming at focus. Nature of the image is real and inverted and size of the image is highly diminished. Object is placed beyond center of curvature. Image will form between C and F. Nature of the image is real and inverted and size of the image is diminished. And coming to here, object is placed at center curvature. Image will form at center curvature. Nature of the image is real and inverted and same size. Object is placed between C and F. Image will form beyond center curvature. Nature of the image is real and inverted and enlarged. So coming to here, object is placed at F. So image will form at infinity. Nature of the image is real and inverted and highly enlarged. Object is placed between F and P. Image will form behind the mirror. Nature of the image is real, virtual, erect and enlarged. Virtual, erect and enlarged. Is it clear? Yes. Now. Say with me, sing with me, learn with me. Dispersion. Dispersion. Say with me, learn with me, sing with me. Dispersion. Splitting a white light into 7 colors is known as dispersion. Come on, say with me, learn with me, sing with me. Dispersion. Dispersion. Splitting a white light into 7 colors is known as dispersion. The band of colors is known as spectrum. What is the phenomena involved in the formation of rainbow? Refraction, dispersion, internal reflection, refraction, dispersion, internal reflection. Say with me, learn with me, sing with me, dispersion. Come on. Say with me, learn with me, sing with me, dispersion. Dun, 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 dispersion. Now we are going to discuss about convex mirror. Convex mirror, convex mirror is known as diverging mirror. Convex mirror is diverging mirror. Convex mirror is diverging mirror. Rules are for image formations. Only two. Image formations only two. So now what are those? We will discuss. Point number one. Point number one. Point number one. Convex mirror. Convex mirror. Pole focus. Center of curvature. Object is at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So after reflection, those light rays are moving away from the principal axis. If you are extending the reflector light rays, those are meeting at focus. Object is at infinity, image is forming at focus. What is the nature of the image? Virtual and erect and highly diminished. Virtual, erect and highly diminished. One, virtual, erect and highly diminished. Second time. Second time. Object is placed at infinity. Light rays are coming from infinity after reflection. Those light rays are moving away from the principal axis. We are extending the reflector light rays. Extended reflector light rays are meeting at one point on the principal axis, that is called focus. So their virtual image is forming. What is the nature of the image? Virtual, erect and highly diminished. What is highly diminished? Size of the image. Next one, second image formation. Convex mirror is also known as converging or diverging. Diverging mirror. Light rays are coming from certain point. So I am taking here object. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. One light ray I am taking. So one light ray I am taking like this. After reflection, those light rays are moving away from the principal axis. When you extended those light rays, those extended light rays are meeting between P and F. What is the nature of the image? Virtual, erect and diminished. Virtual, erect and diminished. Object is placed between P and infinity. Between P and infinity, nature of the image is virtual, erect and diminished. And size of the image. Size of the image is diminished. So nature of the image is virtual, erect. So these are the two image formations. Two image formations of convex mirror. Convex mirror, converging mirror, concave mirror, diverging mirror. Now we're going to discuss about next point is sign conventions. Sign conventions. Sign conventions. Sign conventions. The very important in the history of light reflection and refraction, CBSE grade 10 physics. In that, especially light reflection and refraction, in that chapter, sign convention is very important, very essential topic, very crucial topic, most important topic in light reflection and refraction. Now, I will sing a song. With that, I will explain the concept. Are you ready, all of you? So listen carefully, very important. So for better explanation, close your eyes and listen. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. New Cartesian. Okay, everybody, come on. Sign conventions. So here you can observe I am taking the concave mirror. Pole, focus, center of curvature. Pole, focus, and center of curvature. Pole, focus, and center of curvature. All distance are measured from the pole. All distance are measured from the pole. In the direction of incident rays, object distance, image distance, focal length, and radius of curvature all are positive. Object distance, image distance, radius of curvature, focal length all are negative. Above the principal axis, height of the image and height of the object positive. Below the principal axis, height of the image and height of the object negative. So as you can observe, the coordinate axes, the coordinate the coordinate geometry. So object origin, positive x-axis, negative x-axis, positive y-axis and negative y-axis. So here everything we consider from origin along the incident, along this direction positive, along opposite direction negative, above the principal axis positive, below the principal axis. So here itself same thing we are considering. All measurements will be taken from the pole in the direction of incident as positive, opposite incident as negative, above the principal axis positive, below the principal axis negative. This is about sign conventions. Sign conventions. Sign conventions. Sign conventions. Sign conventions. Okay, sign conventions. And mirror formula, magnification. Mirror formula and magnification. Mirror formula and magnification. So mirror formula 1 by f equal to 1 by v plus 1 by u. 1 by f equal to 1 by v plus 1 by u. Magnification equal to height of the image by height of the object. Magnification is nothing but minus v by u. Height of the image by height of the object. I hope it is very clear to all. So this is about mirrors related to spherical mirrors. So now we will discuss about lenses. So after a small break, we will discuss about lens. So thank you so much for giving the opportunity to teach you all. Thank you for your support. Thank you so much for joining and attending and listening my class. This is Siva sir from Studying the Brand. If you like the content, if you like the channel, if you like the explanation, so do like, share and subscribe to Studying the Brand. So this is Siva sir signing off. Thank you.